Hello students, in the last video we had seen about the DFDs used for some problems and the first level factoring, second level factoring. So let us see the example of that today. Um, See if there is a file containing words separated by blanks or new lines, and you need to count the number of words present in that file. So we have a system, or we can design a DFD in this manner, right? Transformation from DFD to SC as an example. That is, uh, you know, you get the input, like you have the problem. What you are doing, you are actually trying to build a DFD first, okay? Then you are trying to have the factoring. That is, you're trying to get deeper into the problem and trying to solve it, okay? So when you have a file system like that, as I told in the question, it has blank spaces, it has new line characters and all that. So in that case, how will you get a word count? So blank spaces and new line characters should be eliminated, and whatever the words remaining, you need to count those things. Okay. So in general, or in a broader sense, how can we draw the DFD? As input, we get the word list, then the word input. So you sort the list, that is, you make it, you sort the things as a blank space, new line character and the words. Okay, so that is the most abstract input. Okay, so you do that. Then in the function, what happens? The number of words, or number of different words those are present in the file is counted. Okay, then that is given as a print as a count. So number of words present in the file are so and so. Okay, so this is the DFD. Now when we do the first level factoring, what we do, so this is the main program, and the main program only has one type of input, that is inputting the number of the whatever the content the file has. Okay, so that is to just input the content of the file and to get the sorted word list. Sorted word list in the sense, other than your blank spaces and the new line characters, you get the you get the words. What you do, you put it to the main, and in the main, what happens, there is again the function, that is count the number of different words. Okay, total number, how many words are present, you count. You give that back to the main function, and the main function has an again the output module in it, and that gives the output on the screen, like how many number of words are present. In the second level factoring, especially for the input module, okay, it is not for the sorting, for the input of words. So what we need to get, we need to get the sorted list. That is the main thing. So how do we do? You get a word, or you add word to the list. This is the first word when you get. Then after you get the first word, then what do? You go on adding the words. So that goes into the get word list. All the words, whatever is present, that gets into the list. So this happens until when? Until the last word is reached. Then whatever the word input is present, that is given to the sorted list. In the sorted list, that is a the name of the function. Then again sort happens. Sort, why? You need to get only the words that are need to be counted. Okay, so you get the sorted word list. The word list comes in, sorting happens, and number of count happens. Then uh, sorted word list goes to the sorted list function. In the second level factoring is of a sort. That is, you have got the words, that is a word input, you have got whatever the number of or any words that's present in the file you have got. So that is given by what? Count the number of different words. Okay, that comes in, and if it finds a word like other than your blank spaces and new line character, the word goes here. When the word goes here, again that is a scene. same as the previous one or not, because you need to count in the sense it might like either simply count the number of words, or it might eliminate the words that are being similar, and unique words are only counted. So that depends on what function you have written. Okay, so if it all that it is same as the previous word, then it is flagged or something like that. Then it comes to, so if it is a new word, what happens, you need to increment the count, right? So what is the original count that comes in, then the count has been incremented, then again it is sent back to the function count the number of different words. Okay, so this is how it happens. So the next is actually the next unit, that is the detailed design. So what is a detailed design? Detailed design is nothing but once you come up with the problem and you have the requirement specification, you what you do, you come up with the design for that, okay, to develop. So it's not enough you simply, if you roughly design the system. No, what you need to do, you need to design each and everything in a software or to program it. Okay, so what is this? This has been explained in as a detailed design. So detailed design, when you say, the main thing that comes in is a module. You understand, module is a smaller part of the program that has its independent function. So these module descriptions are not detailed enough so that this can be implemented or transformed into code by programmers. So detailed design is necessary, okay, which specifies these modules in a further language that is unambiguous. Unambiguous in the sense that is not in a confusing manner, okay, that is non-confusing, clear and detailed, to an extent that these modules can be coded by the programmers independently. That is, see, simply you don't write in English statements and you don't ask a programmer to do it. What you do, that is a detailed design phase. See, whatever there's given in the specification list as an a natural language, it will be converted into some pseudo codes, or we can say it as a, understandable codes, or in structured English it will be written. So for this, that we call it as a processor module description, how you are actually describing the modules. So processor modules can be described using design specification or description languages, structured English or pseudocode. Pseudocode, you are all aware of it. Decision tables, decision trees. We are not going to concentrate on this to that very much. And other methods are for example, state transition diagrams or formal methods. It depends on the nature of problem that we are having, and depending on the problem we actually choose what the design we need to choose. So what is a module specification? It is informal methods usually lead to different interpretations. That is, see, what one person thinks of as uh, what one person means in a normal English language or a natural language may not be the same as assumed by the other person. So that comes in with the confusion while developing a software. So what we do, formal or semi-formal methods are used to ensure the specifications, and so that there are no multiple interpretation of the same thing. Okay, so these methods are applicable for both function or object oriented designs. It does not depend on the language or the type of language you are using, but it only depends on the understanding of the people actually. So it is ensured that module specifications are complete. It should not be undone or incomplete. Okay, it should be complete. So that it describes the entire behavior of the module, and it should be unambiguous. Okay, as I told you, there should be no confusions in it, and it should be understandable. It should be very easy to understand. There should be no two meanings for the same statement that are using. Okay, so as this has to be implemented by the programmers, that is, the one who is doing the design may not be a developer. So what the designer thinks of designing should be understood by the programmers, okay, who is actually usually not a part of design team. So he should understand it while looking at it. And the formal specifications are usually hard to understand and equally hard to write. So module specifications are implementation independent. That is, it should not specify or suggest any language. Okay, it's not about the language you are using. It's only about the what kind of design you want or what the output should be like. Okay, you can use any of the language, and sometimes it is suggested that if you design in one language, it will be very easy to convert to into another language. There is no that such restrictions, but the thing is whatever you are designing, that has to be proper according to the SRS or what the client actually needs. Whatever you are designing, it should be perfect in that sense. And specification should give the external behavior. The internal behavior details of the module should be decided by the programmer. The designer only will design what the input you have to take and what the output you should get. Whatever in between you do, that is left to the programmer. Okay. um so uh, in 1969, Hoare, he did, he said that inputs and outputs of functional module should qualify some preconditions and post conditions. That is, like for example, if you have to find a square root of a number, then it has to be non-negative and it should be a real number, and whatever the output you are getting is also a positive real number. You know that you don't put a negative symbol for when you are trying to find a square root, and also you are not using the imaginary numbers, right? You are only using the real numbers. So that things you have to keep in mind. So while designing the program also, or while writing the code also, you should be aware of this. So these are like some of the preconditions and post conditions. And older authors, they told it as a structured English for specifying detailed design, and nowadays they call it as a PDL, that is process description language. So ideally, this structured English or PDL is to express a design in a way that is precise and unambiguous. That is, it is understood even by the programmer, and there is no much detail, and he can like just convert whatever is written as a program. Okay, so it has the outer syntax of a programming language. Okay, like a structured programming language, it has a syntax, but it is written in a natural language. So that is that for that we call it as a PDL, or with the help of a structured English we write this. So what is a structured English? So you need to understand that. See, it is used to remove logical ambiguities. That is, see, in a language when you speak, it may sound in a two way. Okay, but when you write it is in a programming language, you cannot have that two-way interpretations. If one statement says something, then it should be the exactly the same thing that it is saying. It should not be like if two-person reads the same sentence, they assume it in a two different ways. Okay, so that for that thing we are using this structured English. So what does it do? It removes the logical ambiguities. Okay, and describe activities performed by the respective process. Exactly what a process does to understand it properly. Okay, you are using this, and various blocks are intended to demonstrate the structure of the process, like how actually the process happens. Okay, to understand this also we are using this, and it can be written if needed, or it can be written in the form of a pseudocode. You understand what a pseudocode is? It's not actually a code, but it is a similar. When you look at it, it looks like a code itself. Okay, computer program itself, and it is near to physical description of the implementation. See, what this structured English comprised of, it has keywords or reserved words, like what we use in our this programming languages, like if then, else, end if, for, read, write, form. All this we have, there's a keywords in our languages, we use it as it is. Okay, and to distinguish from the natural language, we write it in capitals. Okay, so that we understand. For example, it is written as if, then it is a if clause you are using in the program. Okay, that way. And imperative verbs like receive, update, modify, do, iterate, all those things. Okay, and variables like DFD, DD, data elements, data structures. Especially, it is better if you italicize those things. Example, like stock. A student database is usually a name of a database. But if you say students underscore database, it is understood that you need to keep name the table or a database name as a student, mainly the table name as a students underscore database. Okay, so that you understand, especially the programmer understands what you are intending to say, right? So that is it. And the process of module name should be mentioned on the top in all capitals, so that you understand it is a process or a module name. So this is description for a sort module. Sort, you understand, sorting of the numbers also. So see, this is a sort, that is list of integers you need to sort. So input is a non-null L, okay, that is list of integers. Output is, you use a like this, like for all I, 1 is less than or equal to I, less than or equal to I is less than the size L, whatever the number you have put. And what should happen? So L of I should be less than or equal to L of I plus 1. And permutation happens, like any combination of things that need to be. So what you get, whatever the sort you have put, that thing happens in this. See, this is not a language, it's like the pseudocode, you can say. See, this is input, this is the output, so this is how you are getting. Okay, so this is how you write the the PDL. See, for example, if you take an example of min-max program in the sense, in the set of numbers, you are trying to find the minimum of a number and the maximum of the number. So what you do, see, you know the logic behind this, how to find the minimum. Okay, you have done those things. So if you are designing a PDL, so it will be like for example, first thing is the min-max in a file. So you take an array A and do until end of the input, that is until the input is put, you need to take the read the item. So until end of the input, what should you should read an item. Okay, so do until end of input, read an item into A, end do, so you are ending that do. And for max and minimum, so minimum is the first item of A, you first take it as a minimum. Then do for each item in A. What if max is less than item, then set max to the item, that is you first take the first item as a maximum and first item as minimum, and you go on comparing with each next element which you have input. So if it is maximum, then it will swap, otherwise the maximum, whatever the first number you have taken, that will remain. So when a programmer reads this, he understands what needs to be done. But what about the language? He is free to use whatever the language has been either told by the designers, or one of the companies, whatever they are planning to do, in what language they have to told the programmer to do, he can do it. So when you see this is a pseudocode, and you understand easily what has to be done, right? So capital, the reserve words are capitalized, you understand, so this thing has to be used. And see, rest end of the input and all those things are for your understanding, it is in a structured English language, so there is no ambiguity, right? So you understand what actually has to be done in a program. So this is about a PDL. Next, other topics on the unit we'll see in the coming videos. Thank you.